Hi, welcome back to EduHub Academia, the Education for a Better Future platform. We will continue our course of the World of Physics, lecture number 3, part A, by talking about the introduction to classical mechanics. There are 7 major topics of classical mechanics: kinematics, Newton's 3 laws, circular motion, kinetic and potential energy, conservation of energy, linear momentum and collision, rotational motion. We will start by talking about kinematics, and we define it as the branch of physics which studies the motion of objects without considering the forces that cause the motion. Meaning, we will not be talking about dynamics where forces will be involved. So kinematics describes the physical concepts and the relationship between them, such as the following concepts. Distance. It's the total length covered by an object during its motion. It's a scalar quantity, and to refresh your memory, scalar quantity is something that has no direction. You don't specify the direction when you talk about a scalar quantity. Displacement, on the other hand, is the change in position of an object, and you have to specify direction in this case, and that's why it will be labeled as a vector quantity. Speed, which is another scalar quantity, is the measure how much distance an object covers in a certain time interval. As we said, it's a scalar quantity. You don't need to specify the direction over here. However, in velocity, direction is important. Your starting point, your ending point, and the rate of change of displacement of an object over time from a starting point to an end point, which means heading in a specific direction. So that's why we call it a vector quantity. Acceleration, another vector quantity. It's the rate of change or the rate at which the velocity of an object changes over time. Sometimes we simply say it's the rate of change of velocity, meaning how much you change your velocity over a certain period of time or every certain period of time. Change your velocity, whether you change its speed, meaning you go slower or faster, or you change your direction, or both. Momentum, it's the quantity of motion of a moving body or moving object. Again, it's a vector quantity because it involves velocity, as we will see later on. Last one is the energy, and the energy is the ability of any object or any physical system to do work. And it exists in various forms such as kinetic, which relates to motion, potential, position, thermal, heat, elastic, or chemical energy. And of course, in general, energy is nothing but a scalar quantity. Now we come to a very fundamental principle, or the very fundamental principles of classical mechanics, namely Newton's laws of motion. There are 3 laws. We'll start by talking about the first law, which is the law of inertia. Sometimes we refer to it as the equilibrium or the law of equilibrium. What does it say? It says an object at rest tends to stay at rest. An object moving in a constant motion with the same velocity will continue moving with that velocity unless acted upon by an external force. Mathematically, Newton's first law can be represented by this formula. The sum of external forces acting on an object add up to 0. And notice the vector notation. Second law, which is the law of acceleration, it states that the acceleration of an object is directly proportional to the net force acting on it, inversely proportional to its mass. What does that mean? It means more force acting on an object, more acceleration. More mass on an object, less acceleration. Again, mathematically, it's the sum of forces, external forces of course, acting on an object equals to the product of its mass times its acceleration with a vector notation. Don't forget that. Last law, the third law, which is the law of action and reaction. People know that simply by saying for every action there is an equal and opposite reaction. And when we say opposite, it means we need to talk about directions. That's why we put this law mathematically as F on A by B equal minus F on B by A, vector notation. Keep that in mind. Now we come to circular motion. And of course, you can simply say it's an object along a circular path. It involves the continuous change in direction without any change in the speed. You simply change your direction to stay in a circular orbit or motion. It experiences centripetal acceleration directed towards the center of the circle, resulting from the inward net force required to keep it in circular motion. Of course, an object can never ever stay in circular motion unless there is something holding it into the circular orbit, like the Earth orbiting the Sun. There must be a force pushing it or directing it towards the center, which means every time the object tries to stray away, to go away, something brings it back into the circle. Thank you very much. Our next session will be part B of classical mechanics. And please remember to subscribe.